All right, we are learning about radical equations and problem solving. I know I've got this when I can use the Pythagorean theorem to solve problems, use the converse of the Pythagorean theorem, which are called Pythagorean triples, use the distance formula, use the midpoint formula, and solve problems using formulas containing radicals. Some key vocabulary is the Pythagorean theorem, the converse of the Pythagorean theorem, or Pythagorean triple, distance, and midpoint. So the Pythagorean theorem, you need to write this down. If A and B are lengths of the legs of a right triangle and C is the length of the hypotenuse, then A squared plus B squared equals C squared. So this is what you need to write down. A squared plus B squared equals C squared, and C is always the hypotenuse. If you have trouble, you can always draw a picture, like label a diagram, etc. when solving applications if you need help. Always locate the right angle, which will lead to identifying the hypotenuse. In 1a, it says find the length of the hypotenuse. Okay, so we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. A and b, it doesn't matter which is which. They're just the length of the legs. And c is always across from the right angle. It's always the hypotenuse. Okay, so if we solve this, 36 squared is 6 squared is 36, 12 squared is 144. And so if you solve that, that'll give you 180, which we can take the square root of both sides to solve. And then if they want you to round this to the nearest tenth, you would get 13.4 meters. And answers could possibly be an exact value, which would be simplifying the radical, or in decimals. So it just depends on how they want you to answer it. 1b says a 50-foot supporting wire is to be attached to a 75-foot antenna. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 20 feet from the base of the antenna. How high from the base of the antenna is the wire attached? So you can see you're looking for x over here. 50 is across from the right angle, so that's my hypotenuse. So I'm going to say x squared plus 20 squared equals 50 squared. Again, because 50 is across from the right angle. So if I work that out, I would subtract 400 from both sides. And I would get x squared equals 2100. And if I take the square root of both sides, I would get x equals, and I'm going to do it both ways. So if you did it with a decimal, you get 45.8 feet. If you did it with simplifying the radical, you could do 100 times 21. So x could equal 10 square root of 21. Sorry, there you go. Okay. Now here's one for you to do, so go ahead. When you work that out, you should get the unknown leg of the triangle is 4 square root of 10 meters. So here are some for you to do, so go ahead and try. And those would be your answers. Let me know if you're having trouble with that. Okay, so the converse of the Pythagorean theorem says if a triangle has side lengths of a, b, and c, so that a squared plus b squared equals c squared, then the triangle is a right triangle. So it's asking, what it will do, it'll give you 3 different lengths, and it says, is this right triangle? So you have to plug those numbers in, and c is always going to be the longest length, and that could be the possible hypotenuse. And it doesn't matter if it's like in order, c just has to be the biggest number. So determine whether the triangle with given side lengths is a right triangle. So you would plug these into the Pythagorean theorem and see if it makes a true statement. So if I did that, 10 squared is 100. 24 squared is 576. And 26 squared is 676. So is that true? Yes. So since this is a true statement, you would say yes, it's a right triangle. Okay, determine whether the triangle with given side lengths is a right triangle. So again, you plug those in. So you get 49 plus 64 equals the square and the square root cancel each other out, so you just get 110. So if I added this together, I would get 113 equals 110, which is not true. So the answer would be no, it is not a right triangle. To C, you go ahead and try this one. And you should have gotten yes, it is a right triangle. So now we're going to find the distance. The distance D between 2 points with coordinates x1, y1, and x2, y2 is given by the formula D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You need to pause this and write that down. So 3A says find the distance between the 2 points. Okay, so we are going to write the formula down. So we have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is going to be my x1, y1, x2, y2. So basically I just plug in those numbers and see if it works, or see what the answer is. Okay, so x2 minus x1 squared plus y2 minus y1 squared. Make sure that you're doing the correct order of operations, okay? So that would be -4 plus 2 squared plus -6 minus 8 is -14. -4 plus 2 is -2. Okay, so this would be 4 plus 196. So that's the distance of the square root of 200. So I can say that that's the same thing as 100 times 2, right? So I could say 10 square root of 2. Okay, let's try another one. So find the distance between these 2 points. Okay, so distance equals, so x2 minus x1 squared plus y2 minus y1 squared. Double negatives are awful, so let's get rid of those. So we have -1 plus 4 squared plus 5 plus 6 squared. So just do the math. So I get 3 squared plus 11 squared. So I get 9 plus 121 equals the square root of 130, and you can't really do anything with that, so that is your final answer. And again, if they want it in decimals, you could just do that in your calculator. All right, you go ahead and try this one. You should have gotten 20. Okay, the midpoint of the line segment whose endpoints are at x1, y1, and x2, y2 is the point with coordinates x1 plus x2 over 2 and y1 plus y2 over 2. So you're taking the average or the midpoint of this line segment. Okay, so find the midpoint of the line segments that joins those points. So you're going to, again, x1 plus x2 over 2. So you're finding the average of the x coordinates and the average of the y coordinates. So we got -6 plus 4 and 5 plus 8 over 2. So -2 over 2 is -1. And then that will be 13 over 2, which we will not simplify or ever write as a fraction, as a decimal. So that is the midpoint of that line segment. Remember, unless there's decimals in the problem, do not write decimals in the answer, unless it's a real world problem, or if they ask. Okay, find the midpoint of this, so x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, so 2 plus 5 is 7, square root of 5 over 2. And this negative 5 minus 2 is negative 7, square root of 5 over 2. And you can't simplify that, so that is your final answer. You try this one. You should have got negative 9 over 8 and negative 1. I know I've got this one. I can use the Pythagorean theorem to solve problems, use the converse of the Pythagorean theorem and Pythagorean triples, use the distance formula, use the midpoint formula, and solve problems using formulas containing radicals. But do you really understand? What equation could you use to find the width of a rectangle in which the length is 40 centimeters and its diagonal is 41? So this is where you draw a picture, guys. Don't try to do it in your head. So we have a rectangle. We have a diagonal. So the width of the rectangle, find the width. If the length is 40 and the diagonal is 41, what are we going to use? The Pythagorean theorem. Woo! So you get x squared plus 40 squared equals 41 squared. Describe how to find the distance between a point that lies in quadrant 1 and has a point that lies in quadrant 3. Use an example. And then you can look at this example, and they're given a point in quadrant 1, which both would be positive, and in quadrant 3, both would be negative. And so you plug it in the distance formula and solve.